You think a black hole is a hole. It isn't. Not quite. Every diagram you've ever seen, the funnel, the drain, the dark sphere with a glowing ring, quietly lies to you. Physicists have spent a century arguing about what a black hole actually is, and the honest answer unsettles even them. Three of the field's most cited names, Hawking, Penrose, Thorne, could not agree on whether anything truly crosses the threshold. The picture in your head was built for children and stuck. What's really there is stranger, thinner, and far less solid than a hole. Start with the word itself. Hole implies an opening into somewhere, a passage, a throat with another side. That framing was never the physics. It was a translation choice, popularized in the late 1960s because it sounded vivid on television. The original mathematics described something else entirely, a boundary in space-time, not a tunnel through it. The funnel diagrams you remember from textbooks are two-dimensional cartoons of curved geometry sliced flat so a printer could reproduce them. Take the cartoon literally and you get the universe wrong. Almost every misconception that follows traces back to that one inherited image and to the quiet assumption that the picture is the thing. Consider the event horizon. Most explainers describe it as a surface, a dark wall, a one-way membrane, a place where matter is shredded. None of that is quite right. The horizon is not a material. It is not a location you could touch, scrape, or photograph from up close. It is a mathematical condition, the boundary beyond which no future-directed path leads back outward. An astronaut crossing it would, in their own frame, notice nothing. No barrier, no shudder, no flash. The wall is only a wall when seen from outside, and even then, it is a wall made of geometry, not of stuff. The drama you imagine happens nowhere in particular. Then there is the singularity. Pop science calls it a point of infinite density, a crushed dot at the center where matter ceases to exist. That description is a placeholder for a failure. Infinite density is not a discovered feature of nature. It is the symptom of a theory breaking down. General relativity returns infinities at the core because it stops being valid there, the way Newton's equations stop being valid near light speed. Whatever sits at the center is something we do not yet have the mathematics to describe. Calling it a point gives the imagination a tidy object to picture. Reality almost certainly offers no such object and no tidy answer. Here is the reframe. A black hole is not a thing inside space-time. It is a region of space-time itself, folded so steeply that every direction labeled future points inward. Once you cross the horizon, moving away from the center is no longer a question of effort or thrust. It is a question of time travel. You would have to move backward through time to climb out, and time only runs one way. That is the trap. Not crushing gravity, not a wall, not a tunnel. A geometry in which the word outward has been deleted from the local vocabulary, and every clock and compass quietly agrees that there is nowhere left to go but in. This reframing dissolves several familiar images at once. The funnel diagram disappears because there is no spatial down to fall through, only a temporal forward. The dark sphere disappears because the horizon has no surface to be dark, only a shadow cast by light that never escaped. Even the famous spaghettification, the stretching by tidal forces, is not universal. For the largest black holes, the gravitational gradient at the horizon is gentle enough that a human body would feel nothing for hours. You could drift across the boundary mid-sentence and continue talking. The destruction we picture is real for small black holes, optional for big ones, and never the defining feature. What about the glowing ring you have seen in real photographs? That image, captured by a planet-spanning array of radio telescopes, is not the black hole. It is the silhouette of the hole against hot gas swirling outside it, bent by gravity into a near-perfect circle. The dark center is not the object. It is the shadow of an absence, the place where photons that fell in never came back to be photographed. Calling that picture a portrait of a black hole is like calling a footprint a portrait of a foot. The hole itself, by definition, cannot be imaged. We only ever see the rim of what it has erased. The deepest misconception is the quietest one. Most people imagine a black hole as a finished object, formed sitting somewhere, waiting. The mathematics describes something more like a process. Space-time continues to fold. Information about what fell in appears to be scrambled, possibly preserved on the horizon, in a way no one has fully decoded. Hawking radiation slowly bleeds the region back into the universe over timescales longer than the current age of the cosmos. A black hole is less a permanent grave than a very, very slow exhalation. The funnel image freezes a thing that is not still. The real object is closer to weather. So the diagrams are wrong, the metaphors are wrong, and even the word is wrong, and yet black holes remain among the best-tested predictions in physics, confirmed by gravitational waves, by orbital tracks of stars at the galactic center, by that single bent ring of light. Which leaves a sharper question. If our picture of the most extreme object in the universe was this misleading for this long, what about the things we think we understand because they seem ordinary? Next time, we look at the vacuum of space, the empty between the stars, and at why the most boring word in physics may hide the strangest behavior of all.